Ladies and gentlemen, thank you very much for giving me a voice. Today, I will talk about anaerobic digestion, uh, co-digestion of waste, reviewing current status for approaching enhancing biogas production. The work is published by Professor Gomez from University of Leon. So this is few molecular core substrate using anaerobic digestion. Yesterday we talked about molecular, today about open. What is biogas? Biogas main is gaseous product of anaerobic containing methane, carbon dioxide, and little bit of hydrogen, if hydrogen trophic or no. And these are biogas part. When in bottom part, they contain some char and a low acid, and these are true potential how to make. There also sludge, which is unused, can be used as biochar, and rest can be used if lipidic. They can be extracted to fuel case or dust cases. The digested plants can also be an excellent ally for mitigating greenhouse effects. The treatment of organic waste avoids and controls degradation, thus the release of methane into the atmosphere. Biogas obtained from the process is easily valorized for energy production, thermal, electrical, or upgrading to obtain gaseous fuel with similar characteristic to that of natural gas. There is a rising concerning regarding the effects, concentration in the atmosphere, and how the global to the increase in carbon dioxide. Research efforts should focus on attenuating these changes, reducing the negative impact on the economy and searching for efficient ways of producing energy from renewable sources. However, several aspects are still pending a solution, such as the probability of the Gawel treatment system and the need to increase conversion efficiency to reduce installations costs. The anaerobic digestion is usually as inoculum treatment of sewage stream, manure, or of waste, and something from wastewater cycle and from food, because the source is bacteria and soil that occur in soil and manure, and then after specific condition produce methane. Of course, if this bacteria will be treated, then will be stopped methane and will be stimulated to hydrogen production, which is more going in acidic favor and in more in side step before the anaerobic production and producing more volatile acids. So if we focus on volatile acid, we should start look in that process. Novel techniques have been developed of treatment such as ultrasonation, electric fields, the thermal, mechanical, chemical. In this case, the common substrate were used manual residues characterized by high nitrogen and organic content Ammonia is released due to degradation of proteins, reaching a high concentration in the reactor that may inhibit metabolism. On the other hand, ammonia is a good source of hydrogen and other salts can be produced. So the separation and using in removal of energy can be suitable. So we have a lot of here substances, including sulfuric acid, ammonia, that can be in proper time separated from the reaction mixture and used in other processes. So for production. Sewage sludge is another common traditional treated anaerobic digestion. The treatment of urban wastewater leads to rejector stream with a high organic content and significant amount of water. Sludge obtained from the primary settler receives the denomination of primary sludge. The aerobic treatment of wastewater by the waste-activated sludge also gives rise to the sludge stream mainly containing microbial biomass. The rapid growth of this biomass makes the extraction from the biological system imperative, thus producing a secondary sludge or a waste-activated sludge. Anaerobic digestion of food waste or organic fraction gained more popularity in recent years. With the several plants installed treating of material urban waste, sourced separated material is usually preferred to high quality, and food waste generates more matter than other substrates, so mixing with them is highly desired to obtain high metal conditions, as is useful for lignocellulose, as I told yesterday. Yields to enough is initially if without food waste of 70-80%, so less upgraded. But if not properly prepared, there may be 50C or 70. However, in pre-batch market points, the like process is to prepare such process to obtain 80% to continue the scaling up of substance of the process. Lignocellulose permanent crops go to digest biogas, which can be energy production, digested, which is nutrient recovery for fertilizer, as well as the extraction of biofuels. So these are several types which we use, and food waste and sewage sludge with energy crops mixed form the biogas. The sugar rich are most lipid-like because are exothermic in case of methane, while protein and fats are endothermic. So saccharose, however, leads to less methane production. They are more exothermic, so requiring less heat cost. So this is and more profit for same method. And here the yield we have, and we see that from this part, by manure, the biggest is obtained from slaughtery waste and cattle manure, as well as pig manure 05, 056, and somehow in case of greengrass, waste is also useful, very 6 even. So it depends on food waste or optimization and substrate to be suitable for the directed yield. And is first decay, order decay method production. So this is the showing the cases. We need that is pretreatment, also proprietary and some property, so very different, but usually pig manure is higher than cattle because however, cattle manure is more profitable because it produces also um, more production is more profitable. So are hardly desired in case of, for example, Pakistan. So indeed, it depends of region of this and benefits of different reactors. So soil sludge with food waste is benefits increase in energy, but is poor durability. The solid sludge, organic solids waste is increased by biogas in production. Energy obtained was very high, but the trouble on this or this election or low rate of 170 to 218 in Tyrol was that if we increase digester production, the nitrogen backload was obtained and which was trouble, and with in same similarly but in food waste was high nitrogen load in reject water, reduce the water ability, and increase yield for reporting production. So this is the slaughtery waste have disadvantage, high ammonia load, need of iron, chloride, and hydrochloric acid to stabilize with slaughter waste, which in case of organic waste with domestic waste, they note disadvantage only 80% degrees, while in flat waste were also very profitable with no such difficulties. So improving performance is by temperature, depending of mesophilic, hydrophilic, or psychophilic, hyperthermophilic. The increase in temperature accelerates the degradation rates, fluid dynamics, and settling characteristics of particles. The improvement in microbial activity increases the reactor treatment capacity of organics, reducing the digester of volume needed. pH value should be close to neutral conditions, which is stability is very important. The interaction between ionic species in FIFO actually attenuates pH deviation, making the process more robust to organic loading fluctuation and release of carbon dioxide with the presence of ammonia, which needs to be removed. Oxygen organic loading rate is biogas is directly associated to the amount of organic phase, an increment of this parameter is usually related to improvement, but however may also cause imbalances due to accumulation of acid associated with disturbances, the acetogenic and methanogenic phases. Hydraulic rotation time is causes substrate characterized by little method hydrolysis phase will need a higher detention time in the anaerobic reactor. Inhibitory conditions lead to poor performance of the microbial activity, with digestive system not being able to degrade organisms in the time given by hydraulic detention time. Volatile fatty acids are producers imbalance lead to the accumulation of this acid, inhibition of methanogens, and therefore decline biogas evolution. Stable performance when studying Piggy reported more volatile acids, so for pharmaceutics maybe it's better. And ammonia accumulation microfilaments stable performance when treating high nitrogen containing waste. It indicated that ammonia ion there was detrition for experiencing inhibitory conditions. Plays role a buffer capacity to improvement. So they are in several points using. And bioaugmentation is using several techniques for as nanoparticles, bioelectrodes, adsorbent to improve our biochar, to improve the living of bacterial layer. So this is at So for today is all. Thank you very much for listening to me.